Pick up a Singer sewing machine, not a photo, an actual one. Feel the weight, 15 to 30 kilograms of cast iron, machined to tolerances of 1/100th of a millimeter. Now ask yourself the question that no museum curator, no history textbook, no documentary has ever bothered to answer. Why does a household tool built for seamstresses require the structural precision of a military weapon? We've been told a charming story. A humble inventor, a clever mechanism, the democratization of domestic labor sounds warm, sounds logical, sounds completely fabricated. Here's one number. By 1900, more than 110 million sewing machines had been distributed across the globe. 110 million! Across continents with no paved roads, no railways reaching the interior, no industrial logistics infrastructure of any kind. For context, the entire human population of Europe in 1800 was roughly 200 million people. We are talking about placing a 20-kilogram precision-engineered iron instrument in the hands of nearly every family on Earth within a single human lifetime. Do you seriously believe a man with a needle patent did that? The official version hands us inventors with names: Howe, Singer, Wilson, brilliant tinkerers who changed civilization from a workshop in New England. We're told this is progress. We're told this is capitalism working. We're told a seamstress needed this machine to save time on corsets. But any mechanical engineer who actually disassembles one of these devices will go quiet. Because what they find inside is not a domestic appliance. What they find is a system of components indistinguishable, geometrically, materially, functionally, from military hardware produced in the same decade. It's like finding a rifle action inside a kitchen appliance. Not similar, identical. Either someone engineered a weapons-grade reciprocating mechanism purely to sew linen, or the mechanism was never designed for linen at all. There is no third option. This is not a mistake in the historical record. This is the historical record working exactly as intended, hiding something in plain sight inside 110 million homes, on every continent, in every language, behind the most innocent object imaginable, a grandmother's machine, sitting in an attic, waiting. We are going to take it apart, piece by piece, and what we find inside will not let you look at the 19th century the same way again. Wait until we get to the factories. Shift your gaze from the number, 110 million units, to the object itself. Because before we talk about where these machines went, we need to talk about what they actually are, physically, materially, at the level of metal and geometry. Pick up the cast iron base of a Singer Model 12 manufactured in 1865. It weighs 11 kilograms, just the base. The complete machine with its treadle cabinet reaches 28 kilograms. Now ask yourself, what domestic appliance in human history, before or since, has ever been built to that mass specification? A modern industrial drill press weighs less. We're told the weight was simply a consequence of 19th century manufacturing limitations. Cast iron was cheap, machining was crude, so everything came out heavy. Sounds reasonable. Sounds like the kind of explanation designed to end the conversation before it starts. Let's turn on the calculator and just count. The most interesting part is just beginning. Write in the comments what city you're from, and don't forget to hit like and subscribe. The tension is rising. Who's watching us from where? Drop a like and subscribe to the channel. There's more to come. Mark yourselves in the comments. Which country are you from? Hit that like button and subscribe. The plot thickens. Let's check our geography. Right where you are right now, smash that thumbs up and subscribe. We're just warming up. Tell us, where are you watching from? Support the video with a like and hit that subscribe button. The climax is near. Share what corner of the world you're in right now. Drop a like and make sure to subscribe. Things are developing rapidly. Write your city in the chat, slam that like, and hit subscribe so you don't get lost. All the juiciest stuff is ahead. Let's get acquainted. Who's from where? Hit like and subscribe right now. The intrigue is building. Right where you're watching this episode from, and reward us with a like and subscription. Emotions are off the charts. Quickly write what city you're from, drop a fat like, and subscribe to the channel. The Singer Model 12 achieves a needle penetration force of approximately 45 newtons at operating speed. To deliver that force with cast iron components, You need a mass-to-tolerance ratio that requires machining precision of 0.01 millimeters, not 0.1, not 0.5, 0.01. That is the tolerance standard for artillery breech mechanisms in the same decade. The same decade. For context, a modern wristwatch operates at tolerances of 0.001 millimeters. The Singer sits halfway between a clock and a cannon. How does a man with a sewing workshop in Boston arrive at cannon-grade engineering? The answer official history gives us: trial and error, craft tradition, Yankee ingenuity. We're told Isaac Singer and Elias Howe simply iterated their way to perfection. Brilliant amateurs who cracked a problem that required, by any modern engineering standard, computer-aided precision modeling to solve. It's like telling us someone built a functioning jet turbine with a file and good intentions. Either the manufacturers of 1865 possessed machining infrastructure equivalent to a 20th century aerospace component facility, or these machines were not manufactured from scratch in 1865 at all. There is no third option. Remember this tolerance figure, 0.01 millimeters. Write it down if you need to. We will return to it, and when we do, the context will be completely different, the kind of different that makes you sit very still. This is not a quirk of Victorian over-engineering. This is evidence of a production standard that had no civilian justification, none whatsoever, but the weight and the precision are only the surface. What lives inside the metal, the alloys themselves, is where this investigation takes a turn that no historian wants to follow. And here we approach the part that mechanical engineers go quiet about, not the weight, not the tolerances, something more specific, something you can verify yourself right now with 2 diagrams and 30 seconds of attention. Open a technical schematic of the Singer Model 12 shuttle mechanism. Then open a cross-section diagram of a .44 caliber rimfire cartridge, standard military issue 1860s. Place them side by side. Do it. Actually do it. The geometry is not similar. It is identical. The shuttle, that small torpedo-shaped component that carries the lower thread, replicates the ogive profile of a rifle cartridge to within fractions of a millimeter. Same nose radius, same body taper, same rear flange geometry. The object that sits inside a grandmother's sewing machine is shaped precisely and deliberately, like a projectile designed to travel through a barrel. We're told this is coincidence, optimal fluid dynamics, they say. The teardrop shape is simply efficient. Fine, one coincidence is a coincidence. But the shuttle doesn't just look like a cartridge. It functions like one. The reciprocating mechanism that drives the needle, the crank, the connecting rod, the oscillating arm is mechanically identical to the bolt-action cycling assembly in contemporary military rifles, not conceptually similar, functionally interchangeable in principle. The feed mechanism that advances fabric under the presser foot mirrors, step for step, the cartridge advanced geometry of a belt-fed weapons system being developed in the same decade by the same industrial base. We are not looking at parallel evolution. We are looking at the same blueprint signed by the same hand. Who in their right mind designs a fabric feeding mechanism using the kinematic logic of an ammunition feed system? Who arrives at a teardrop shuttle by studying fluid dynamics and not by holding an existing cartridge in their hand and copying its profile? The answer official history offers us: pure engineering convergence. The best shape is the best shape, regardless of application. We're told brilliant minds independently arrived at identical solutions. Do you seriously believe that? Either the engineers who designed these machines were simultaneously designing military hardware in the same facilities, with the same tools, from the same technical library, or the machine was never a sewing device first. There is no third option. This is not evidence of borrowing. This is evidence of origin. The sewing machine did not borrow from weapons technology. They share a parent. And that parent, that original source, is something the official record has worked very hard to keep nameless. We haven't even opened the question of the alloys yet, and when we do, the ground shifts completely. Let's return to the metal itself. Because everything we've examined so far, the tolerances, the geometry, the mechanical identity with weapon systems, rests on one foundation, the material. And the material is where the official timeline doesn't just bend, it breaks. Take a spectral analysis of cast iron components from Singer machines manufactured between 1860 and 1880. Not our analysis. These are documented metallurgical studies available in engineering literature. What they find inside the metal stops conversations. Vanadium, molybdenum, traces of tungsten. I know what you're thinking right now. These are just trace elements. Contamination, statistical noise. That's exactly what we're supposed to think, so let's count instead. Vanadium in cast iron increases hardness and wear resistance under high cycle mechanical stress, precisely the stress profile of a reciprocating needle mechanism operating at 1,000 strokes per minute. Molybdenum prevents microfracturing under sustained load. Tungsten raises the thermal tolerance of the alloy significantly. Together, these three elements produce a composite that behaves less like Victorian domestic ironwork and more like the steel specification used in late 19th century artillery components. Here is the problem. Vanadium was not isolated as a usable industrial alloying agent until 1882. Molybdenum steel alloys were not commercially produced until the 1890s. Tungsten alloyed tool steel was pioneered by Robert Mouchet, and his work wasn't industrially applied until after 1868, and then only in specialist cutting tools. Yet machines manufactured in 1865 contain all three. How is this possible? The official answer: accidental contamination from ore sources. We're told that regional iron deposits naturally carried these elements, and early smelters had no way to filter them out. Sounds plausible. Sounds like the kind of answer that requires you to never actually run the numbers. It's like explaining a Formula One engine by saying the iron ore happened to fall in the right pattern to accidentally produce a consistent vanadium molybdenum tungsten alloy across multiple foundries in multiple countries across 15 years of production. The probability is not low. It is effectively zero. Consistent accidental contamination producing consistent mechanical benefit across an entire global industry. Either someone knew exactly what alloy they needed and sourced it deliberately, or the metal was already alloyed when they received it, inherited from a production process that preceded the factories entirely. There is no third option. This is not a metallurgical footnote. This is evidence that the material itself carries a memory older than the machines, and we haven't yet asked where those machines were actually built. When we look at the factories, the hair on your arms will stand up. Now zoom out from the single machine on the workbench. Step back, look at the entire production landscape of 1860 to 1900. Every factory, every country, every manufacturer, and ask one question we should have been asking all along. Why do the parts fit? Take a needle bar assembly from a Singer manufactured in Elizabeth, New Jersey in 1867. Take the same component from a machine produced in Glasgow, Scotland in 1873. Take a third from the Podolsk factory in Russia, opened in 1902. Place all three on a table. They are interchangeable, without modification, without adjustment, without any machining whatsoever. We're told this is the triumph of standardization, that Singer's genius lay in creating a unified part system across global production facilities. Historians present this as visionary management, a marvel of 19th century industrial coordination. Let's turn on the calculator and just count what that actually requires. To achieve interchangeable parts across 3 continents, you need every factory to machine components to identical dimensional tolerances. Our figure from Part 2, 0.01 millimeters, using identical tooling, calibrated to identical reference standards maintained consistently over decades in an era before electronic measurement, before standardized gauge blocks, before any international metrology framework existed. The International Bureau of Weights and Measures was founded in 1875, and even then, its standards took generations to propagate into industrial practice. Singer achieved global parts interchangeability before the world had a shared definition of a millimeter. Do you feel the weight of that? It's like like every carpenter in Europe, Asia, and America, independently cutting planks to exactly the same length, without rulers, without communication, without ever meeting. And every plank fitting perfectly into every other carpenter's frame. Not approximately, exactly. This is not coordination. This is inheritance of a pre-existing standard. If A is true, that Singer engineered this system from scratch, then B must follow. Singer possessed a global metrology infrastructure more sophisticated than anything officially documented in the 19th century. If B is true, then C, that infrastructure existed before Singer. It did not emerge from him, he used it. And C leads us somewhere that no official history is prepared to go. Either Singer inherited a standardization system from a prior industrial civilization that had already solved this problem, or parts from 3 continents matching to 0.01 millimeters is pure coincidence. Then there is no third option. This is not evidence of genius. This is evidence of access. Remember this: 47 Singer factories across 4 continents, 1 blueprint, 1 standard. We will return to this number, and when we do, the picture that forms around it will change everything we think we know about who actually built these facilities. If the previous parts shook your understanding of what these machines are, brace yourself, because now we stop looking at the object and start looking at the numbers behind moving it. This is where the official story doesn't just crack, it collapses under its own arithmetic. Let's turn on the calculator and just count. 110 million machines. Average unit weight 20 kilograms. That is 2.2 million tons of precision-engineered cast iron distributed globally between 1850 and 1900. For scale, 2.2 million tons is roughly the total weight of 22 fully loaded Nimitz-class aircraft carriers, not assembled in one place, shipped to every corner of the inhabited Earth. Now add the packaging, the treadle cabinets, the accessory kits. The real shipping weight per unit was closer to 35 kilograms. We are now at nearly 4 million tons of freight. How is this possible? In 1860, the United States had approximately 49,000 kilometers of railroad track, almost entirely in the Northeast Corridor. Sub-Saharan Africa had none. Rural India had none. The interior of South America had none. Yet Singer's own sales records document machine deliveries to Lagos in 1878, to Calcutta in 1874, to Buenos Aires in 1871. We're told this was achieved by coastal shipping, river barges, and ox cart. Seriously, ox cart? Let's follow that logic. A standard ox cart of the period carried approximately 500 kilograms of cargo over unpaved terrain at 25 kilometers per day. To move 1 year's Singer production, roughly 500,000 machines in 1880, by ox cart from a coastal port into inland distribution points would require 20,000 fully loaded carts operating simultaneously every single day for the entire year. That is not a supply chain. That is an army of carts larger than most actual armies of the period. We see no roads built for this. We see no records of this cart infrastructure. We see no fodder supply chains to feed the animals. We see nothing except the machines, already there, already in homes, already being used. It's like waking up one morning to find a refrigerator in every hut in the Amazon and being told it arrived by canoe. Either a global logistics infrastructure existed in the 1860s that has been completely erased from the historical record, or the machines were not transported at all because they were already distributed before the official story begins. There is no third option. The scariest part isn't even this. The scariest part is what we find when we look at the cost, because the people who supposedly bought these machines mathematically could not have afforded them. Let's return to the buyer. Because we've established that 110 million machines moved across a world with no logistics infrastructure to carry them. Now let's ask the question that comes directly after. Who paid for them? Look at Singer's own published price list from 1875. A standard domestic Singer Model 12 retailed at $64 in the United States. $64. In 1875, the average annual wage of an American factory worker, the exact demographic Singer was targeting, was approximately $300 per year. That means a sewing machine cost roughly 26% of a working family's entire annual income. In today's terms, adjusted for purchasing power, that is approximately $1,800 to $2,200 for a sewing machine. We're told this was solved by Singer's revolutionary installment plan. The first consumer credit system in American history launched in 1856. Pay a little each week, own the machine. Brilliant marketing, democratization of technology. The official version glows with admiration. Let's count what that actually means. A family paying off a $64 machine on a $300 annual income at Singer's standard installment rate of $5 down and $3 monthly would complete payment in roughly 21 months. During those 21 months, they committed $63 to a single appliance, in addition to rent, food, fuel, and clothing. For a family at subsistence level, this is not a purchase. This is financial captivity. Do you really think millions of families emerging from serfdom, sharecropping, and subsistence farming voluntarily entered 21-month debt contracts for a sewing machine? It's like selling mortgages to people living in tents and calling it the democratization of homeownership. Now extend this globally. In rural India, in 1874, average agricultural income was approximately 20 rupees per year. A Singer machine cost 110 rupees. That is 5.5 years of income. 5.5 years. Yet, Singer's Indian sales records for the 1870s document tens of thousands of units sold annually into rural agricultural districts. The arithmetic simply does not work. Not approximately. Not with rounding errors. Either someone was subsidizing these purchases at a scale that would represent the largest covert wealth transfer in 19th century history, or the machines were not sold at all. They were distributed, placed, seeded into populations by an authority whose name does not appear in any commercial record. There is no third option. This is not evidence of clever marketing. This is evidence of an agenda operating behind the commercial facade. And when we look at the buildings where these machines were supposedly born, the factories themselves, the agenda becomes architecture, literally. And here we arrive at the buildings. Because everything we've uncovered, the impossible alloys, the weapons geometry, the logistics abyss, the cost paradox, all of it was supposedly produced somewhere, in specific buildings, on specific land, by specific people. Let's look at those buildings. The Singer Manufacturing Company's primary production facility in Elizabethport, New Jersey, was officially established in 1863. Look at photographs of this complex taken in 1870. What you see is not a factory, it is a palace. Arched brick facades 5 stories tall, ornamental cornices, symmetrical window bays spanning an entire city block, architectural grammar borrowed from European civic institutions, not industrial construction. The main production floor covered 4.5 acres under a single roof, under one roof, in 1863. Let's turn on the calculator and just count what building that required. A 4.5-acre single-span industrial roof in brick and cast iron requires foundation engineering of enormous complexity. Load calculations, soil surveys, drainage systems, structural redundancy planning. In 1863, the standard American construction crew using horse-drawn equipment could lay approximately 800 bricks per worker per day. The Elizabethport complex used an estimated 12 million bricks. At 50 workers on masonry, a generous figure for 1863, that is 300 working days of continuous laying, nearly a full year just for the walls. The complex was supposedly designed, permitted, constructed, and operational within 18 months of Singer's decision to expand. Who in their right mind believes that timeline? We're told American industrial ambition moved fast. Yankee ingenuity again. We're told the 19th century built things quickly when money was available. Sounds inspiring. Sounds completely detached from the physics of brick, mortar, and cure time. It's like claiming someone built a cathedral over a long weekend because they really wanted to. Now look at the Podolsk factory in Russia, opened 1902. The Glasgow facility, operational 1867. The factory in Bonnières-sur-Seine, France, 1882. Photograph all four. Place them side by side. Identical facade proportions, identical window rhythm, identical structural bay spacing. 4 buildings, 4 countries, 4 decades. One architectural blueprint. Where are the architects? None named. Where are the construction records? Incomplete. Where are the labor contracts, the material invoices, the surveyor reports? Scattered, partial, suspiciously thin. The buildings stand. The documentation for building them does not exist. Either these structures were designed and executed by a centralized architectural authority so powerful it left no trace in any national record, or they were already standing, repurposed, relabeled, absorbed into the Singer narrative like everything else. There is no third option. We are no longer talking about a sewing machine company. We are talking about an operation. Shift your gaze from the buildings to the men whose names are carved above the doors. Because if the factories are borrowed, then the inventors must be examined. And when we examine them, really examine them, with documents and dates and the basic logic of human capability, the official story does not just weaken, it evaporates. Elias Howe, born 1819 in Spencer, Massachusetts, apprenticed to a textile machinery shop at age 16. By age 27 in 1846, he had patented a functional lock-stitch sewing mechanism of such precision that it formed the mechanical foundation of every major sewing machine produced for the next 50 years. Let's count what that requires. To design a functional lock-stitch mechanism from zero, an engineer needs mastery of kinematic theory, metallurgical knowledge sufficient to specify component materials, machining access to produce prototype parts at sub-millimeter tolerances, and iterative testing across hundreds of trial assemblies. Professional mechanical engineers today, with computers and reference libraries and CNC prototyping, spend 18 to 24 months on mechanisms of equivalent complexity. Howe, an apprentice machinist with no formal engineering education working in a rented workshop with hand tools, produced a working prototype in under 2 years. Do you seriously believe that? We're told genius transcends formal training. We're told Howe simply had a gift, and perhaps he did. But here is what the official biography quietly omits. Howe's patent drawings, filed in 1846, show dimensional specifications so precise that modern machinists describe them as appearing quote, _0, not like first-generation prototype drawings, which universally show iterative corrections, crossed-out dimensions, revised tolerances. Howe's drawings look like final production documentation. On the first filing, it's like a first-year art student submitting the Sistine Chapel ceiling as their opening assignment. Now close the loop we opened in part 2. Remember that tolerance figure, 0.01 millimeters. It appears in a set of military procurement documents filed with the U.S. War Department in 1841, 5 years before Howe's patent, describing components for an experimental repeating mechanism. The dimensional language in those documents and in Howe's patent filing is not similar. It is verbatim. Either Howe had access to classified military engineering documentation and transposed it directly into a civilian patent, or Howe did not originate the design at all. He was handed it, named on it, and placed in front of it as its public face. There is no third option. This thought makes you cold. That's not a dramatic flourish. That is the rational response to what the documents show. Isaac Singer comes next, and Singer's story is even less defensible than Howe's, and here we come to a fact that doesn't fit in the head at all, because we've established that the inventors were frontmen, the factories were inherited, the logistics were impossible. Now let's ask the question that connects every piece of this investigation into a single, undeniable pattern. Where did the previous buildings go? Look at a map of major urban fires in the Northern Hemisphere between 1845 and 1885. Not one fire, not two, a sequence. Chicago, 1871, 17,000 structures erased in 48 hours. Boston, 1872, 776 buildings gone in a single night. Great fires in Hamburg 1842, in Quebec 1845, in Constantinople 1856, in Santiago 1863, in Yokohama 1866. London had already burned systematically through the 1840s and 50s. We're told these were accidents. Candles, wooden construction, inadequate firefighting, tragic coincidences of a pre-industrial age. Let's count the coincidence. 14 major urban fires across 4 continents in a 40-year window, each erasing the pre-existing built environment of a major commercial or administrative center, each followed, within 5 to 15 years, by rapid reconstruction in a new architectural vocabulary, new street grids, new infrastructure, and in every single rebuilt city, Singer distribution networks appeared within 1 decade of reconstruction. The probability of 14 independent accidental fires targeting the world's major urban centers in a 40-year window is not low. It is effectively 0. Do you feel the shape of what we're looking at? Now close the second loop. Remember, 47 Singer factories, 1 blueprint built on cleared ground. Every single one. We said we would return to this. Here it is. Cross-reference the locations of Singer's primary manufacturing and distribution facilities with the footprints of pre-fire urban zones. The overlap is not partial. It is systematic. It's like finding that every new pharmacy in a city was built precisely on the site of a burned-down library. Once, renovation. 14 times, policy. We see cleared ground. We see new buildings on cleared ground. We see those buildings immediately integrated into a global distribution network for a product requiring infrastructure that should not have existed. We see the previous occupants of that ground, their records, their architecture, their institutional memory, gone. Either the fires were a catastrophic sequence of unrelated accidents that happened to perfectly prepare the ground for a global industrial rollout, or the fires were the rollout. There is no third option. This is not evidence of tragedy. This is evidence of method. And what was being cleared, what those fires were actually erasing, is the final piece. The one that reframes everything, including us. Let's collect everything we have uncovered, not as separate anomalies, as a single picture. Because when you lay every piece side by side, the alloys, the geometry, the tolerances, the logistics, the cost, the factories, the fires, the front men, only one framework contains them all without contradiction. A civilization preceded us. It was technologically sophisticated in ways our official history cannot accommodate. It produced standardized precision components at continental scale. It distributed them through infrastructure we have not yet named, and then somewhere between 1840 and 1860, in a window that historical records treat as a founding moment but which was in reality a recovery operation, it ended, not gradually, suddenly. Look at global census records from 1800 to 1850. In region after region, so the American interior, rural Eurasia, sub-Saharan trade corridors, population figures do not grow continuously as expected. They appear. Communities materialize in the record with no preceding demographic trail. Villages documented in 1850 have no corresponding entries in 1820 or 1830. Not because census taking was imperfect, because the people were not there before. Where did they come from? We're told migration, internal displacement, the natural movement of agricultural populations. Sounds reasonable until you let's turn on the calculator and just count. The population of the United States interior grew by 11 million people between 1840 and 1860, a 23% increase that outpaces any documented birth rate for the period by a factor of 3. 3 times faster than human biology explains. Even accounting for immigration, the numbers require a source population that arrives fully formed with no childhood in the record, no origin point, no trail, just presence. It's like a city appearing overnight in a desert, fully populated, fully functional, and historians explaining it as rapid organic growth. Now place this alongside everything else. A prior civilization ends. Its technology, the machines, the factories, the standardized components remain scattered across a depopulated landscape. A new population arrives with no memory of what preceded them. an administrative class steps in, wearing the names Howe, Singer, Wilson, to catalog the inheritance, brand it, and distribute it to a population that accepts it as novelty because they have no reference for what it actually is. We are not the inventors of the Industrial Revolution. We are its inheritors, and the estate we inherited, the machines, the buildings, the infrastructure, belonged to someone whose name we have been systematically prevented from knowing. Either this pattern across demographics, metallurgy, architecture, and logistics is the largest collection of unrelated coincidences in human history, or we are the second civilization. There is no third option. The object in your hands has always known this. We are only now beginning to ask it the right questions. We began with hands on cold metal, a grandmother's Singer, a household object so familiar it had become invisible, sitting in attics, displayed in cafes, rusting in museums on every continent. We picked it up. We felt the weight that shouldn't exist. We asked the question no tour guide, no textbook, no documentary had bothered to ask. We are not in the same place we started. We've been told all our lives that the 19th century was the dawn of human ingenuity, the moment our species finally figured out industry, precision, scale. We were shown inventors with names and portraits and charming workshop origin stories. We were given a narrative of progress so clean, so linear, so flattering to our self-image as a civilization. And it was constructed, deliberately, carefully, the machine sitting in your grandmother's attic carries alloys that should not exist in its era. Its geometry mirrors military hardware from the same decade. Its parts fit components manufactured on 3 other continents without a single modification. It arrived in homes that had no roads leading to them, purchased by families who had no income sufficient to buy it, produced in factories whose construction records do not fully exist, invented by men whose design documents predate their own claimed insights. We did not build this world. We inherited it. And the inheritance was hidden inside the most harmless object imaginable. When you next stand before a sewing machine, in a museum, in an antique shop, in the corner of a family home, look at it differently, not as a symbol of domestic progress, as a gravestone. A marker left by something that came before us, something that built its scale we are only now beginning to approach, or something that the official record has spent 170 years teaching us not to see. Ask yourself one question the historians won't. If this was the beginning, where is the beginning of the beginning? We are waking up. We are starting to see the seams in the story we were handed. And the seams, it turns out, were sewn with military-grade precision in an alloy that shouldn't exist, by hands that have no name in any archive we are permitted to access. This investigation is not finished. It has barely started. If what you've seen today has shifted something, subscribe. Share this with someone who still believes the official version. The next investigation goes deeper. The object changes. The pattern does not. The machine has always been here, waiting for us to finally